Okay, so here we have to solve this radical equation. 3/4 times the square root of x minus 3 minus 1 is equal to 5. And so the way we're going to do this is we want to isolate the radical. Get the radical all by itself, and then we can square both sides. And right, we know that square is the opposite of square root, and so they'll cancel each other out. And then allow us to solve for x. So that's our strategy. So how are we going to isolate this radical? Well, first off, we can add 1 to both sides. And so we get 3/4 times the radical is equal to 5 plus 1, or 6. And then we're going to sort of divide by 3/4, or in other words, multiply by 4 and divide by 3. Either way, you might have to do this on a calculator or just multiply by 4, right? Get rid of that in the denominator. 6 times 4 is 24. Divide by 3, 24 divided by 3 is 8. And so again, we have the radical square root x minus 3 is equal to 8. And so now we can square both sides in order to cancel that square root out. And so on the left, all we're going to have is x minus 3. On the right, we have 8 squared, or 64. Now it's a pretty simple linear equation. Just add 3 to both sides, and we get x is equal to 67. But whenever you square both sides of an equation, you may introduce fake roots, or what they call extraneous roots. And so we have to check that our answer is true, right? It works for the actual original equation. So let's do that, right? Plug 67 back in for x in the original equation. So here I have 3/4 times x, right? 67 minus 3 minus 1 equals 5. Let's check both sides are equal. 67 minus 3 is 64. And the square root of 64 is 8. And so 8 times 3/4 is, well, 8 times 3 is 24. Divided by 4 is 6. Minus 1 is indeed 5. And so there you go. That means x equals 67 is indeed a solution to this equation.